Good morning, everyone. It's a pleasure to be here today with Critical Insights to talk about the Sustainable Data Center. The focus of today's discussion will be on whether we really are serious about creating a more sustainable future and what's being done in practice to progress towards this sustainable data center. So we have three industry experts with us, as Kaylee mentioned. We have John Booth, Astrid, Wynne, and Stephane Cardot. So perhaps I can start with allowing each one of them to introduce themselves. So perhaps, John, would you like to start?
Good morning, everybody. Can everybody hear me okay? Great. Yeah, so I'm the Managing Director of Carbon Through IT Limited. We're an energy efficiency and sustainability consultancy, and we're working with some of the most interesting projects happening in Europe at the moment. So EcoDC in Sweden. I'm actually in Stockholm at the moment, and I apologise for my cold, because when we arrived on Sunday, it was proper snowing. I mean, properly snowing. Our plane was delayed, and it was been snowing for the last 2 days. So it's about 8 inches deep at the moment.
Thanks, John. Stephane, should we go to you next?
Yes, good morning, everybody. My name is Stephane Cardot. I'm part of Quantum. For people who don't know Quantum, basically we're a hardware and software vendor really focused on storing the data. So we're providing storage and software across all data center worldwide for various type of customers. And my role is pre-sales for the global EMEA team. Thank you.
Thanks, Stephane. And Astrid.
Hello, I am Astrid Wynne, and I am Head of Sustainability at Techbuyer, which specialises in circular economy approaches to IT hardware, predominantly product life extension. I'm also Head of Sustainability at Interact, which looks at energy efficiency for different makes, models and configurations of servers. And I'm also a chartered environmentalist, which means that I'm qualified and do give training on sustainability to our workforce and our partners. And I'm also the chair of the Sustainability Special Interest Group at the Data Center Alliance, where I work with John on kind of trying to evolve approaches beyond the usual tales of just energy efficiency into something a little bit wider, trying to push it into other areas.
Amazing. Thank you. So let's get started with today's discussion. As we all know, digitization drives efficiency across all sectors, be it virtual meetings like these to avoid people flying around everywhere, or AI-driven insights to streamline manufacturing or logistics. But every digital process goes through a data center. So achieving a sustainable data center will require a focus on the IT technology, the infrastructure, and also the ability to measure the work that's being done. So this is exactly how we will structure today's segment. So to kick off on the IT technology piece to our panelists, how do you see the interplay between technology, both from a hardware and software perspective, and energy efficiency in data centers? Astrid, should we lead with you on this, perhaps?
Yeah, it's a big question. I think historically we've relied on technology to dig us out of a hole. We've relied on the fact that Moore's law has meant that each successive generation of hardware will automatically become more efficient than the last. And we know that truth is no longer the case, that Moore's law is slowing down. And that means that we have to have a more evolved approach to how we build the hardware. It's the hardware that has the energy draw. You can optimize the software on top of that, but it's the hardware that's plugged in. And so you have to examine that more carefully, specifically at the server level, because the servers are responsible for a large amount of the energy draw of the building. The IT load is approximately 70% of the energy draw, according to a lot of studies. So if you optimize that hardware and the IT, then you'll reduce your energy load. I think historically we've had a focus on PUE, which has looked at the cooling and infrastructure side. We've missed out the one in that ratio. And so we kind of need to focus on that. And that means understanding at machine level what's happening, what happens when we change make and model, but also what happens when we change the configuration of servers. So we've looked into this, we've released studies on it, we've demonstrated that you can get an immediate past generation to outperform the latest generation in terms of compute power and energy efficiency, which has all sorts of implications on what we do about circular economy. There has been an assumption for a while that we can't really have a full circular economy with our hardware because we're going to lose on the energy side. That's no longer true, and the industry really needs to focus on that and examine what it's doing in order to get the best outcomes.
Yeah, I love that analogy of, the focus on the PUE, the one being on the technology side, and then the 0.3, 0.4, whatever else being on the infrastructure side. Stephane, can I draw you into this conversation and, allow you to comment and perhaps also touch on data classification and how and where data is stored and the impact of that?
Yeah, so being a hardware and software vendor, what we do generally to fit the challenge that today everybody's facing, because they need more compute, more performance, more storage, and they need to keep the data forever. It's not keeping the data for a few months, a few years now, it's keeping for the data forever. So when we develop the products, anyway, we capitalize on making sure the products first are either high density to minimize the footprint, that is key for the data center. We must make sure that the device which are used storing the data, like technology like disk, are having the most density. So that means we're speaking about maybe 20 terabyte hard disk today. Of course, we need to speak about also flash disk, SSD, and NVMe, because those disks also are very power efficient versus, I would say, the mechanical disk. So we develop all these products, and as well as the power supplies on these servers, these storage, they also have to be very efficient depending on the load that it's being put on the box. So that's why you have that 80 plus also compliance with certain level of certification. And we are roughly having platinum, or I would say the most gold or even beyond certification. So the hardware is really key today for us to make it more dense, less power consumption, to give out the better performance. I'll speak about data classification after, of course. What people need to look also, and as Astrid was saying, is the software, because on top of the hardware, you can have smart software which will enable to do some saving in terms of storage efficiency. So you can hear some words like compression since many years. You can hear some words like deduplication algorithm, which will try to shrink as much as possible the data which is being stored either on primary storage or secondary storage for archive and backup. And you also have erasure coding technology like are used on the cloud vendors, which are also in the data center, which allows to build efficient storage, I would say, in terms of disaster recovery, because erasure coding is a mathematical algorithm which will geo-spread the data across maybe multiple sites, having an overhead maybe only a 60% versus 300% if you are doing the basic replication. So the software are becoming more and more intelligent. The last point is the data classification, but I think we'll touch on that also a little bit later, is that today, as I was saying, people want to keep the data forever, or people will not delete the data because they don't know what it is and they don't want to make an error. So what is important for most of our customers now is really to understand what they are storing and put the I would say the data which requires the most compute and power on maybe the latest type of technology, performance drives, performance compute, and the data which is more kind of not even access often, maybe once a year, two or three times every 5 years, that should go on different type of technology. So that should be stored, I would say, on S3 type of technology, tape technology, whatever. So this is a key important thing that today people need to look at, is the data classification and put the appropriate data on the proper technology, without also compromising the data protection. Like Paul was speaking about cybersecurity, moving the data to cheaper technology, yes, but that cheaper technology also needs to have immutability features to protect trust data. Okay.
Thanks, Stephane. And John, it would be great to hear your views also on this interplay between technology and energy efficiency, and also perhaps all the work that the Commission is doing on defining some of these terms like data and hardware.
I just want to go back a bit, actually. Would the rest of the panel agree with me that the moon landings back in the late 60s, early 70s were probably the pinnacle of human endeavor in the last 50 years? Would you agree with me on that? Sending people to the moon?
Think not. I'd like to think we're heading forwards and that we haven't peaked.
But do you not think that, you know, creating a vehicle that took 2 men into space and then landed them on the satellite that revolves around this planet is probably the greatest human achievement in the last 50 years? It's a simple question.
I have to think about, no.
No, you don't think it's simple, okay. Well, what I was going to say is, right, is that I'm holding up my mobile phone, right? This has more power in it than NASA used for the entirety of the space program. And they did it, and they used their, you know, very basic computing, but they got men on the moon. We haven't done that for the last 40 years, right? And you know, they were given, they had to use what they had. And what they had was short memory blocks. They had minimal computing equipment, and yet they got people into space and landed on the moon and brought back samples. We, as a society, have got technology that gives us more, you know, manufacturers provide smaller chips, faster chips, more powerful chips, large amounts of data, a storage capability, and we fill it up with dancing cats, right? We as a species, we really fundamentally need to find out exactly what we're doing, because at the moment we are prolific wasters of this technology that we are using. And because of this, we are building ever bigger data centers, buying ever bigger equipment and storage, and we're wasting precious resources that we could be using to address the climate change problem and flooding and all of that sort of stuff that's going to come about from the global warming perspective. Technology should be used to, deal with this crisis, but we don't seem to be using it for that. And I think we need to really fundamentally think about how it is we're going to do stuff moving forwards.
Yeah, thanks. Oh, sorry, go on, John.
And in terms of what the Commission are doing, obviously we have the Green Deal, and there's a lot of focus in the Green Deal on data centers. There's 3 separate pieces of legislation that are going to look into data centers, and primarily they're looking at the building side of things, which is really, you know, we're getting blamed for the mistakes of the IT manufacturers in addressing the one. So our technology needs to be doing more with less, and we're getting hit for that. And I think we'll cover the legislation in the later session.
Yeah, okay. Thanks for sharing that, John. And that's a really great segue because, you know, having spoken about what's going on the technology side, I do want to move into the infrastructure side. So we can stick with you on that. It would be helpful to get some color on how data center infrastructure can better match the IT hardware that it hosts.
Yeah, so at the moment we're kind of we're over-engineering data center estates for our technology, our servers and stuff, and the memory. For a kind of false perception that we need to be up 24/7, 365. But you know, when we talk about dancing cat videos, you know, they don't need to be up there. And I think it goes back to Stephane's point about how we classify data and where we store it and how we store it. And I think we do need to define data again. We need to look at data and say, is this really useful data, or is this just a nice to have? Does it matter if we lose it? You know, and how many instances of dancing cat videos are there globally stored in data centers using energy? A picture of a dancing cat can be put in a book somewhere and it doesn't use any energy. But a video of a dancing cat online is probably consuming, thousands of hours of kilowatts of energy. And I think Rabbi mentioned Dispatchio, one of the videos, the YouTube video that's been watched the most often. It was the power equivalent to Venezuela over a year for one video. We really do have to think about that. Well, one video is equaling the entire power consumption of a small Latin American nation. That can't be right.
Mm-hmm. So yeah, sticking with the infrastructure side and building what John has said in terms of the energy use or energy draw as a result of the workloads that are hosted in various data centers, it would be good to also understand more comprehensively. So looking at circular economy, recycle, reuse, and how that is impacted by the workloads that are within the infrastructure. So Astrid, can I turn that over to you, perhaps to touch base on the circular economy piece?
Yeah. So for those not familiar with circular economy, it's essentially trying to create a closed loop system where we're designing out waste, and we are using existing resources to develop new components and parts and machinery is on the industrial side. For technology, that's quite difficult at the moment because the recycling technologies are not there yet to recover the materials that we need at scale, and also to use those recovered materials in new equipment. So I'm specifically thinking of critical raw materials here, which are present in trace amounts, or they're present in amalgams. Now, conventional recycling technology will shred and melt in blunt terms, which means that a lot of those materials are burnt away. So for the technology sector, our best bet for the medium term is to reuse as much as possible. That's kind of the core of where we're trying to get to. And we're doing that because it enables us to reduce our mining of virgin resources, which means that we're keeping them in the ground longer. We'll have less environmental damage associated with mining, which has, problems of air pollution, water pollution, human health. Social impacts are significant as well. So we're reducing all of that, but we're also buying time for recycling technologies to develop. So we've got things on the horizon like bioleaching, like pyrolysis, which are much more efficient recovery mechanisms for the materials that we need, which, by the way, are in demand by the IT sector, but also by the renewable infrastructure sector. So we really need these materials. What we're trying to do is extend product life to give those technologies time to develop and give the designers time to reassess how they're going to design not just the components of the equipment, but also the materials that they use to make the whole process more efficient. So that's kind of why we want product life extension in a data center. Now, what that looks like is actually much more varied than you might expect. So when people think about product life extension, they think, oh yeah, refurbishment. That is not the only model that you need to be looking at. You need to be looking at cascading assets, for example, within your own organization to areas that can take a lower compute machine and deliver what you need in that area. You also need to be looking at selling your existing equipment to other organizations with lower compute needs who might like, to make an analogy, a Mini versus a Ferrari. A Mini does them just fine for what they need. Give the Mini to them so that it doesn't go to waste and so that we're not manufacturing new equipment. Mm-hmm. And then another key aspect to think about is rebuilding what you already have. Now, Google have been very public about the fact that I think 19% of their deployed servers are remanufactured machines. I think that's the right statistic. And that almost half of their components are refurbished components, i.e. they've been restored to factory condition and they make no distinction between new and refurbished in their spares and upgrades program. Now, that's been out there for years and years and years, like since 2016, I think that report came out. The question is how you can replicate that in an environment where you don't control the entire IT supply chain. You're not the designer, you're not the manufacturer, you don't have an in-house refurbishment arm. Well, there are a couple of ways that you can do that. Firstly, you can make yourself aware of a secondary market so that you can obtain a refurbishment function in your own organization, which you can either use yourself or use to make sure that your equipment gets to a second user and is not just shredded and burned. Another thing is that you could potentially talk to the manufacturers about, can I have an alternate product for this? Can I have spares and upgrades built into my contract so that I have the option to extend product life? But the other really important thing that you need to do is you need to understand what the energy component of that spares and upgrades refurbishment program is, what that circular economy function does to your energy usage. And for that, you need to understand the energy draw of the machines, the bare metal servers. So whatever you load onto that in terms of software exists on something that's efficient as possible. And you can do that by grading your machines. So we've got a tool which does that, that looks at the make, model, and amount of memory that a machine has, the CPU model, the number of CPUs, and then it will run that through analysis and give you a grading on the servers. So the idea is that if they're graded A to F, you would get rid of the Fs, take them out of your estate and migrate that workload onto other more efficient servers. But it also means that you can reconfigure existing servers that are in that mid-range and get a higher energy efficiency score. So we know that when you play with the amount of memory that you've got on your machines, that will have an effect on how efficient things are, because there will be a tipping point where too much memory is actually just taking all the draw and giving you nothing back in return. So that's one example on the server level. You need to be doing the same thing with, as far as possible, with all your other machinery. And then you need to be examining what the energy cost of this is and what the material cost of this is. And you're going to be trying to balance those two. It's not easy, but it is necessary. We can't rely on the old simple mechanisms that we had before, like Moore's law, to kind of hide that in a corner for us, because those rules aren't true anymore. And we are under pressure in terms of materials for the equipment that we're using in the data center sector. And that material is needed by other sectors that are trying to dig us out of the problem of climate change. Does that answer the question?
It does. It's a great answer. Thank you. Thank you for explaining that so well. So I'd like to pick up on that, Stephane, with you. So, Astrid drew out the story of reuse, remanufacturing, refurbishment to really make the best use of the equipment that is already there. How do you see that balance out with cost and some of the supply chain challenges we're seeing right now?
Yeah, so jumping on what Astrid said, this is the role of kind of what I do or my pre-sales are doing, is like when we work with customers for their data center, the first thing is always to look what they have, where they want to go, and what we can reuse within their existing architecture, maybe as a secondary task, because they require less maybe performance. So we kind of take that hardware solution and put it back for a different task, or just like Astrid saying, these sometimes big customers have multiple data centers, some branch offices, which requires that level of performance. So we try to be smart as possible, because that's what people are requesting, first for saving, but also they are more and more concerned about, I would say, the green IT at some point. So that is the first point. I was speaking about, she was speaking about it also about secondary market, which of course, most of our partners are also buying back this type of materials and putting that back to other type of different user out there on the market. And that is key. The only thing that people needs to be vigilant is the maintenance, the maintainability of those system, because as every vendors, we provide system to last at least 7 years in terms of service. After that, in terms of cost, spare parts, the price are kind of ramping up. So that also is a tricky thing to take into account when you're thinking long-term, is the price of the support, the maintainability, without putting in jeopardy also the data which is on those type of storage. After that, you have alternative technology which can store the data not only 7 years, but much more, like 30 years. But these are like tape technology, more for archiving purpose, which all the hyperscalers are using to store, I would say, all those funny images or videos at the best cost. So yeah, so what we also see is that people want to reuse or keep as long as possible. That means we also need to develop products which have such scalability. As Astrid was saying, we have to have products which have the capability to be maybe modified, to add more storage, maybe more resource, more RAM, more CPU within the time of their use. So that is also key for us vendors to think about the capability of upgrading those products as they grow, as the customer requires performance. And also that capability is right now very used because we're starting to speak about the supply streams. And yes, the market out there is really constrained around the hardware, I would say, which is capable to come out of the factories. So we have some chips or other components where we have a huge shortage, and sometimes that takes 6 months, 9 months, 1 year in some products to get those out there. Every hardware vendor has such problematic. So it is really key for the end users to have the existing solution to be able to scale and go over sometime the end of life announcement, because those shortage are going to continue to come. They're not going to be solved in a few weeks because the pandemic is over. It will take a lot of years. And unfortunately, this is due maybe to the pandemic, but those are also due to political sometimes situation that we can see right now.
Thanks.
Can I just make a quick point on what something Astrid said? So you said that a lot of companies are looking to use refurbished equipment. Is that right? It should be in their procurement policies to reuse refurbished equipment. Is that correct, Astrid?
It should be. I mean, it's coming out of government, and they're asking the supply chain to do the same thing in the UK. So if they're not now, they should be. But you know more about this, John. So
I do, yeah. So you're absolutely correct. So it is a government policy actually in the ICT 2020 to 2025 strategy for most government departments to at least consider the use of refurbished equipment, which is fantastic on the face of it. There's only one problem. When you speak to government departments and mention that that the government policy is that you should be using recycled kit, they look at you as if you have just said that you're going to knock the building down brick by brick and rebuild it on a floodplain, right? They're simply not interested. People have been conditioned to be wanting faster, better machines. And this, unfortunately, is part of the whole problem we're in, right? You know, why do manufacturers have 3-year refresh cycles on their equipment? Why are people being forced to upgrade their equipment, which is perfectly serviceable, in relatively short periods of time? Because it matches the technology companies' business models. They want to have a guaranteed income stream. Those business models are flawed, right? If we're in a climate emergency and we've got resource problems, which Stephane has just mentioned, right? We simply can't keep taking stuff out of the ground, making computing equipment, not really recycling and refurbishing it, and then just basically chucking it into the growing e-waste pile, which is absolutely causing environmental devastation in China and parts of Africa, where they are trying to recover the most basic of precious metals, not critical raw materials, the most basic of raw, like gold and copper, right? They're trying to recover them in probably the most unenvironmentally friendly way possible. So they have got a lot of problems that we need to address, and we need to address them really, really quickly. You mentioned earlier about a lot of our critical raw materials are going to have to be used by other sectors, notably the power sector, right? You know, you're talking about data centers, say in Europe, the FLAP markets, France, London, Amsterdam, Paris, and Dublin. 3 of those are under moratorium at the moment. You cannot simply get the power, right? And then we've got Copenhagen, Oslo, Stockholm, and Helsinki, and they themselves have power issues. There is a brick wall approach in, right, where we're not going to be able to expand. So we're not going to, Stephane's not going to get his critical raw materials to make his data units to be installed in data centers because the data centers will not have the power to power them up. We are in a serious problem. And unfortunately, at the moment, everybody seems to be not thinking it's their problem. And we need to address that really quickly. You know, these are the forums that we should be doing that. People need to really think about it as what they're doing.
John, you raise really important points around the constraints that exist today and the constraints that are fast approaching. You know, given all of your experience with the European Commission, taxonomy, all of the work around measurement and auditability, can you talk to us about what you were hearing and seeing there?
Yeah, so as I mentioned earlier, the 3 main pieces of legislation that are coming down the tracks that will affect data center operations globally, and I think that will have a knock-on effect on everything else. So the first one is the EU Taxonomy Regulations. Now, this is part of the EU's Green Deal. So basically what it's saying is if you're making an investment, and it's not just for data centers or computing, it's for every single thing you could think of, you need to be really evaluating what it is that you're going to be doing. But for data centers, they've specifically targeted us, and they've basically said that all your data centers should be independently audited every 3 years to the best practices of the EU Code of Conduct for Data Center Energy Efficiency, or its equivalent, the CLC/TR EN 5600 99-1 Best Practices for Efficiency. Now, back in May, some of the auditing companies kind of raised a little query with DG Connect and said, neither of those documents are in an auditable state. So they need to be redrafted so that we can go into an organization and basically do a tick sheet and then provide the technical verification document to the non-financial auditor to present it to the financial auditor so that they can justify to their investors that they have basically done what the taxonomy regulations require. So we spent most of the summer redrafting, and the drafting committee finished their work probably end of September. It was passed over to the EU's Joint Research Centre for their technical oversight. They made a couple of amendments which were adopted, and then it went to public consultation, and that public consultation period finished last Wednesday when I was in Dublin. I've just earlier today sent a message to the chairman of the drafting committee and said, have we had any feedback? I'm still waiting an answer. But once that happens, then that will need to be required and done. So the taxonomy affects 11,000 organizations within Europe. And you think on the face of it, oh, it's just a factor in Europe. But no, it has a global impact. So we're currently working with an investment trust based in the UK that has European investors, and I've had this confirmed by DG FISMA, which is the financial auditors and regulators for the Commission, for a data center build in the US. So I've got to go to Austin early next year, and believe me, there's no problem with me going to Austin. Quite like the city, it's a great place, to conduct an audit on a US data center under the EU taxonomy regulations. So effectively, if you have European investors, any data center that investors are invested in will fall under the compliance regulations. And that's in the US, in Europe, and in Asia Pac and China, I'd imagine. So it will have an impact. And our environmental kind of conditions for data centers in Europe are probably 5 years in advance of any other region on the planet in terms of what we are doing. So anyway, so the best practice we've done, but The other thing to mention is that the Corporate Sustainability Reporting Directive, which now covers a further 50,000 organisations, and these are the customers of the colos and the cloud boys, they need to report their information as well. So in certain cases, they're going to be knocking on the door of the data centre and saying, we've got cloud services with you, we need to know how much carbon and energy we're using. Or they might be going to co-location data centres and saying, we've got 10 racks with you, we need to know how much energy and carbon we're using in your estate. I don't think data centre operators realise the complexity of what they're going to be asked to provide in terms of data. But they better get on it really, really quickly, because otherwise they're going to have potential, I'm not going to say fines, because I don't think there's any mechanism within the taxonomy regulations for an operator to be fined, but it could lead to reputational risk. And organisations will vote for their feet with their feet. If they are in that current data centre and they need to get that data and they won't get it, they could move to another organisation and where they will get the data. So I think that these guys really need to play carefully with that. And finally, the most pressing one, which probably won't come in until 2024, but it's the redrafted Energy Efficiency Directive. And in that document, we are seriously tasked with A, providing total energy consumption for the data center, B, the percentage of that is derived from renewable energy, water usage, and if used, any waste heat that is being delivered to other secondary sources. There is also a proposal to have a mandatory in-country registry, data center registry, so that this is where that data would be reported to. Now there is currently a consultation exercise taking place. The first meeting will be next week or the week after, but I expect there to be quite a significant amount of negotiation and to-ing and fro-ing and horse trading that will go on. But the people that have designed the recast directive have been pretty clear. I think the main sticking point is how low the bar is going to be. Right? So, and I can see somebody did mention to me 100 kilowatts. So 100 kilowatts brings into play most edge sites, but also small on-premise data centers. And I think the kind of focus here is, let's get all of those probably very high energy consumers that are on site that haven't been optimized, owned by enterprise organizations, and say, you know what, this isn't efficient. You need to be putting your IT into highly efficient cloud data centers where the data center is optimized. So actually, on one hand, it's good for cloud operators, but they will have to provide individual data for each of the customers that are moving into the cloud.
Yeah.
So those are the three things. The most pressing, I think, is the taxonomy, because that will be done and dusted, and the first period of reporting is mid next year. Then we've got the CSRD, which is 24, and then we've got the Energy Efficiency Directive, which is 24 as well. But that's only 18 months away.
Yeah, well,
Right?
it's fast approaching.
Yeah.
Yeah, I mean, that's a really helpful summary of the different pieces that are kind of approaching us and kind of the ripple effect that they have not only in Europe, but beyond. I'm mindful of time, and I want to give Astrid and Stephane an opportunity to comment and make their
Sorry,
own.
Aashna, just to interrupt you. We've got plenty of time because we had to cancel the session, so feel free to take your time to ask questions. I just wanted to let you know.
Okay, perfect.
Okay, well, just one more point then.
Yeah, go ahead.
Yeah, so the current taxonomy regulations, we've basically, that's the first edition, right? So the best practices is the first edition. The second edition, which will be implemented at an unknown date, will be based upon the EN 5600 5-1 data center maturity model. There is a version of that that's available now to purchase. It's the 2021 version. And if I would advise anybody in the data center sector who's offering these services, they need to look at that. They need to purchase it, and they need to look at it, and they need to understand it in depth, because the next version of the taxonomy regulations will apply to the next version of that document. Now, because I'm the chair of the BSI TCT 73 committee, I have had visibility of that draft. And I know that that is the one that's going to really scare the horses.
Yeah. Okay, thanks for adding that. Like I said, it's a really helpful summary of the different initiatives that are underway. Astrid, I'd love to draw you into this conversation and comment on, the need for measurement at this stage, and also if you think it is comprehensive enough or you feel like something is still missing.
I don't know as much as John knows about how things are measured and how effective they are. I do know that a lot of the measurements are on ratios. So far, a lot of the standards are on ratios rather than actual measurements, although hearing John speak, that looks like it's about to change. So that's good. My view on how much is getting reported is a little bit more nuanced, I guess. I'm glad that we've got some legislative thumb screws put in place for actually proper transparent reporting, because it's been very difficult to understand exactly what's going on with reporting so far when you look at the sustainability reports of companies, because it's such a large area. Trying to get to the detail of what they've put within their boundaries and what they haven't becomes very difficult. For example, some of the software companies won't be reporting the energy component of their software at end user phase, which kind of seems a little bit backwards to me, because that's where they make their money. The networks wouldn't be using that energy if they didn't have the software. That makes that monthly income for the organizations. So there's that. The other thing that I'm kind of quite curious about is that the things that are being measured are tighter versions of what was already recognized as an issue for data centers and digital, i.e. energy usage, renewable supply, and water, which are the three key points I've understood from John, although please feel free to jump in, John, if I've got that wrong. No.
I've just literally got a message back from the drafting committee with the public consultation comments. I was just quickly going through them to see if there was anything that I should mention.
Okay.
But you're right, Astrid. So it's energy efficiency, there is circular economy, there is energy reuse, so heat reuse, for example. Recycling, like John mentioned.
So a lot of that is around the pressing issue of climate change, and us surpassing the climate planetary boundary. But there are 9 planetary boundaries. And we haven't addressed all of them by any stretch of the imagination with these legislative levers, and then consequently what data centers are aware of. Now, I'm a realist, and obviously we're not going to all become eco-warriors and go and read the Stockholm Institute and say, oh my God, we're surpassing 6 of the 9 planetary boundaries, and what we're going to do about novel entities and, land use change and all the rest of it. But I think as organisations, we could do better, and we perhaps should be doing better, bearing in mind that this is one of the sectors that's growing out of all the industries. Data centres are expected to grow by 500% by 2050. As you've rightly pointed out, they're seen as the answer to a lot of our environmental problems. It's a way that we dematerialise and enable social development within planetary boundaries. Well, if we're going to do that, then we need to assess all the other issues now before they become an issue, before we kind of have a laser focus on carbon to the exclusion of everything else, and then set ourselves up for an equally large, if not larger problem later on down the line. John's written about this. I'm sure Stephane knows a lot about it as well, and I haven't read what he's written. But we've got problems with materials already, not just the critical raw materials, but things like copper, which is jumping in price. If you do quick maths on the energy supply for nations, we can see that the energy demand is going to increase by something like 85% in the UK once you transfer the boilers' energy usage onto that, and then the car fleet onto our current energy usage. If you do a quick calculation on how much land that's going to take to produce the renewables for that supply, you realise that it's much bigger than the space of the UK. We can't get there with renewables. I'm not so stupid as to think that we're just going to do renewables, but that's kind of an indicator of some of the issues, some of the bigger issues that we're facing, especially when you know that because of the issues around climate change and water scarcity, we're probably going to have more of the world's population condensed into a narrower band of the earth. We've got all sorts of issues about food production associated with that. I don't want to be too doom and gloom, but I think we should be looking at these issues now when we're trying to obtain some solutions and not fall into the same trap as we've always done, which is think with our lizard brain, solve tomorrow's problem and set ourselves up for a big issue in like 20 years' time.
Yeah. Thanks, Astrid. As you were talking, I could see both John and Stephane nodding their head in agreement. So Stephane, can I invite you to make your closing comments, because I'm conscious we're at 11, so we're
no problem. So I'll be very more practical because I'm a vendor, so I'll be practical, and I'm a data center architect. So I would just to close is really what the most, and I'm coming back to the initial data classification. It is more likely important that people really need to understand what they have in their data center. It is important to understand how they work that data. So that means vendors like us and other vendors need to fulfill software which enables people within the data center, customer, to understand how their storage is being used in terms of capacity, in terms of workload. So they have capability of having dashboard. All those by APIs can be driven by AI, and the AI also can perfectly give some figures on how all this is being used and maybe overlap with power consumption at the same time. Because in fact, when you say we're putting workloads on it behind the scene, we're putting more power. So it is key that in the future, there is more software which enables people to understand what type of data they have. That means we speak about metadata more and more. So software which understand the metadata, and depending on the metadata of the data, put that data at the proper device and overlap that with some AI functionality, which may automatically move the data, reduce that, in that case, power consumption. And on top of that, of course, vendors like us need to also continue and pursue to deliver hardware which is much more efficient, much more, I would say, supporting lifetime. So not 3 years like John was saying. Now we see tenders with 5 years, 7 years of contract, and we fulfill 7 years of support on such product, and we sell those products during 7 years. And of course, allow those products to be scalable as much as possible, and develop software which enable to squeeze as much as possible data in the storage. Okay.
Just one final point, if I may. So, if you were on one of the Apollo moon missions, and one of the people on in the capsule decided to start burning a piece of wood or an oil can inside the capsule, I think the others would have kind of jumped on him and stopped him doing it, because they were going to pollute the atmosphere in the capsule. Would you agree with that? What's the difference between the capsule and the planet? Because the planet has got a finite kind of, it is a capsule that's hurtling through space. And we have people on this planet who are actively burning stuff and polluting the atmosphere. And we should be stopping that from happening. Now, that's a wider thing outside of technology. But, the same thing applies. We are literally in a small, self-contained, fully self-supporting moon capsule would just happen to be hurtling around the sun.
Yeah, that's fair food for thought, and I think something to leave our audiences to reflect over. So thank you so much, John, Astrid, Stephane, for that conversation, and thank you, Kaylee and Critical Insights, for hosting us.